Greetings everyone, this is Noran Expert here back again with another video. Today we'll be solving problem number 30 and difficulty it's been rated at is medium. This problem was asked by Facebook and let's just get down to it. So you are given an array of non-negative integers that represents a two-dimensional elevation map where each element is a unit width wall and the integer is the height. So suppose it will rain and all the spots between the two walls gets filled up. Now what we want to do is we want to compute how many units of water remains trapped on the map in O of n complexity and O of 1 space. For example, given the input 2, 1, 2, we can hold 1 unit of water in the middle. Um, and again, you can sort of pause this thing, go through it on your own. But this is a pretty famous problem, and on LeetCode, it's called the trapping rainwater problem. And we'll just go over there. So as you can see, it's been rated as hard and they've given a pictorial description. Again, you can pause this video, try to solve it on your own. And obviously the LeetCode link will be given in the description below. But basically, if you have two walls of, let's say, some height, for example, this is of height 1 and the next one is of height 2, the water which will be trapped would be of unit 1. Now, the way to sort of go about this is actually pretty simple if you sort of know what it is. But before that, we'll just write a few base conditions as we usually do. So we'll just write if there is no height which is given, then we just return 0. So again, the way to sort of solve this problem is actually pretty simple. All you want to do is you just want to make a left array and a right array. So what I mean by that is that you will create an array which will go from the left hand side and calculate all the max heights that's encountered so far. So the left array would be 1, then 2, then 3 till here. And then we would also have a right array which will traverse from right to left, which will also contain the maximum height it's encountered so far. So same logic, you have 1, then 2, then 3, and then so on. So the way we can sort of use those values then is by basically computing or sort of iterating all the elements one by one, and we would know what is the maximum height that is between the elements. So for example, if you're at index 2, which is 0, the height is 0, we would know for a fact that the left longest height which is there is 1, and similarly the right uh, largest height is 2. So you would sort of make a minimum of those two and then calculate it accordingly. Again, it's a pretty simple problem, so let's just get down to it. So the way we can start is by creating a left array which has sorry, which has a number of zeros. All we're doing is we're just creating um, an array left of length height with all the values as um, 0, and the same thing for right. Now the way we're going to start with this is by basically saying that left 0 is going to be equal to height 0 because you need to do comparison, and the same thing for the right as well. So the last element inside right is going to be equal to the last element inside height, and the way to denote that is by -1, so they'll pick up the last elements from there, right? And now all you want to do is you want to iterate through all the elements and then fill the left and the right values. So let's fill up the left values first. So let's do that for I in range. So we need to start our iteration from 1 to n rather than from 0 to n. The reason for that is just because we already have a pre-filled value at 0. So we start from 1 to the length of height. Cool, good enough. Now all you want to do is for each left eye element, you just want to save the maximum element which has been encountered so far. So you do left I minus 1 and the height, which has been encountered so far. So all this would do is it will just create whatever is the max which you've got so far on the left hand side, right? And same thing for let's fill up the right area as well. The way we can do that is by doing an iteration from right to left. but we need to start from the second last element, so we'll be doing that. Again, if you don't know what this convention is doing, it's basically doing an iteration from the second last element to the very last element, um, and the number of steps it's taking each time is -1. Right? Uh, Pretty simple so far, and we just need to fill up these values. So let's just do that. Right? I is going to be equal to max of right I plus 1 and height I. Again, all you're doing is what's the maximum of right that we've encountered so far, and that's all that we're storing. Cool. So actually, let's just do a quick print of left and right so that we get an understanding of whether everything's working correctly. And it's running. So you can see this is the maximum height from left to right, and the same thing from right to left. Cool. So all we want to do now is basically we want to run an iteration for all the values or all the heights which we've encountered so far. So let's do that. But before we do that, we need to create a variable called water because we'll keep on appending inside of it and we'll return the water variable at the end. So all we want to do is we'll do for I in comma v enumerate. This enumerate is basically due to the fact that we want the index as well as the value. And what we'll do is we'll just say water is going to be equal to, now the computation over here, if you sort of take this example, is that you take the minimum height between the right and the left. So let's do that. So we'll just say min left I, oops, and same thing for right I. So whatever is the minimum value which we have, and sort of, um, just use that and just negate it by the value of the water that we've sort of gained so far. So that we'll do -v, and that's basically it. So again, if you didn't understand what's happening over here, it's pretty simplistic. All we've done is we've created a left array and a right array which sort of contains what's the maximum height we've encountered so far, and it just goes on from there. So for example, over here, what's going to happen is left would be 1 because that's the maximum that we've encountered so far. Our right would be, I'm assuming it should be actually 3. So that is going to be there, but the minimum is 1. So 1 minus the value, which is 0 over here. So only one water value can be contained. Then the same thing sort of applies over and over again. Cool. So let's just run this code. Hopefully it should run for us. It's taking a little bit of time. Just okay, cool, everything is coming perfectly, and let's just submit this. Hopefully it should run, and you can see it's running. It's not the most fastest solution, and the reason for that is actually because we're using a lot of other variables and we're using a left and right array to compute all those things. But there are multiple ways of sort of solving this entire problem. But since we need to do it in O of n complexity, this is the best approach to go about it. Cool. So that's it for today's video. If you have any doubts or if you want me to explain something a little further, do leave it in the comments below. Again, we would love to hear back from you. And if you did like this video, do give a like and do subscribe to the channel. We are discussion over here and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it. And have a great day. Thank you.